The method of undetermined coefficients is used for second order and higher order equations, but in this case, for this worksheet, we are going to focus on second order differential equations, in particular non-homogeneous ones, and that is when the g of t function, or the right-hand side, like in this first problem, is not zero, and the coefficients on the left-hand side are constant. The way this method works is by making an intelligent guess, and that is, I see for this first problem that there is an exponential on the right-hand side, and so I need to make a guess for y. Y obviously is not going to be a sine or a cosine function or a natural log, because no number of derivatives of sine, cosine, trig, or natural logs is going to give me an exponential function back, which is what I want to get the left side to equal the right side. So then that means that an exponential function is most likely the correct form. But I could get a little bit more detail and realize it's not going to be e to the negative t, because no derivative of e to the negative t will ever give me an e to the 2t, which is the function I have in the non-homogeneous portion for this problem. So my guess is going to be, and this is problem 1, that the particular solution y sub p is of the form ae to the 2t. That's my guess. It's called the method of undetermined coefficients because in my guess I have a coefficient that has yet to be determined, but part of the process is to actually go ahead and figure out what is the value of a that is going to satisfy that equation. Once I make this intelligent guess, then I need to get the appropriate derivatives and substitute in. So the first derivative is 2a e to 2t. The second derivative is going to be 4a e to the 2t. And then when we substitute in, we're going to get 4a e to the 2t, that's y double prime, minus 3 times y prime, so 3 times 2a, which is 6a e to the 2t, minus 4 times y, which is 4a e to the 2t. Now notice that this simplifies to negative 6a e to the 2t. And that's plugging in to the left side. Now, for my guess to be true, it must equal the right side, which is 3e to the 2t. And the only way that's going to be is if negative 6a is 3. And that is only going to happen when a is negative 3/6, or more simply, negative 1/2. And then that means that my final form of the particular solution is negative 1/2 e to 2t. Right, so this is the portion of the general solution that will give me the non-homogeneous part. Let's look at another example. I'm going to go to problem 2. I've already written the solution here, but I'm going to talk you through it. It's a little more effort, which is why I wrote it in advance. We have the same left-hand side for the differential equation. It's not required. I just did for simplicity, but the non-homogeneous part changed. Now over here, the non-homogeneous part is now 2 sine t. I'm going to guess y equals a sine t plus b cosine t. Now, after that first example, that may not have been your first guess. You may have just guessed a sine t. But the problem is that y is going to be sine, y double prime will be sine, but y prime, the first derivative of sine, is going to be cosine. So if you only had the first entity here, in my guess, you'd have sine and cosine inside your left-hand side function after you sub in. And the cosine actually matters. You can't ignore it. So in order to counteract the cosine appearing, I threw in a second term, which is the b cosine. And that's because for that term, y is going to be cosine, y double prime will be cosine, but y prime is going to have a sine in it. And so the a's and b's are going to work out so that the cosine portion disappears. So as I did in the first problem, once I make my guess, I then need whatever derivatives the differential equation has. And so I've got y prime and y double prime written next. And then I substitute in to the left-hand side. So this first parentheses is my y double prime minus 3 times y prime minus 4 times y. And then I start simplifying. So I start factoring based on the trig function. So the first term has a negative a sine minus 3b sine minus 4a sine. So when I simplify, that gives me negative 5a plus 3b sine of t. And then I do the same thing for the coefficient of the cosine term, and I've got negative 3a minus 5b. This has to equal, remember, that is the simplification of the left-hand side of the differential equation after we subbed in our particular guess and its derivatives. This must equal the right-hand side, the non-homogeneous portion of 2 sine t. But I wrote in here in red a hidden cosine term, which is 0 times cosine t. And I did that because for the left-hand side where we have sine of t, its coefficient is negative 5a plus 3b. That must equal 2 because that's the coefficient of the sine term on the right-hand side, which is my first equation here. And then you have negative 3a minus 5b is the coefficient of cosine on the left-hand side. And you have to set that equal to something, and realizing that there is a cosine on the right, it's just multiplied by 0, indicates what that coefficient must be. And so that is where my second equation here came from. From this point, there's a variety of ways that you could go about solving for a and b. I like to recognize that the b term in the first equation is positive but negative in the second, so if I could somehow get them of the same magnitude and add, the b's would disappear. And so I do that by multiplying the first equation by 5 and the second equation by 3, which gives me what I have in green in the middle of the page on the bottom here. Negative 25a plus 15b equals 10, and negative 9a minus 15b equals 0. So when I add these two equations, the b term cancels out. I have negative 34a, and that equals 10. And so when you solve for a equals negative 10/34, or negative 5/17. If we go back to the left, I use the second equation then, just because it's simpler, and I solve for b. So I bring 5b to the right, divide by 5, and I've got b is negative 3/5 a. We already just found a, so if I substitute that in, negative 3/5 times negative 5/17, the negative signs cancel out, the 5's cancel out, and we're left with 3/17, which brings me to the orange now, because now we have a and b. We've determined the coefficients, so I substitute into our particular solution guess, and we've got yp equals negative 5/17 sine t plus 3/17 cosine t. It's at this point, some students do forget or match up the a with the wrong trig function or vice versa. So do be careful and be sure that you substitute the coefficient into its appropriate place. There are a couple of other problems that are continuing here. I will give you the solution, but I will leave it to you to do for practice. Feel free to email if you have any questions. The solution for this third one is going to be as follows. So this is the first term plus 2/13 e to the t sine 2t. Again, that is the final solution for your particular after you've determined the initially undetermined coefficients. And the solution for problem 4 is going to be longer. It's going to be a combination of the solutions for all of the first 3 problems. So we've got negative 1/2 e to the 2t minus 5/17 sine t plus 3/17 cosine t plus 10/13 cosine 2t plus 2/13. There should be an exponential in here. And in this first one, there's an e to the t. And here it's e to the t sine 2t. Again, that should match the solution for part 4, 1, 2, and 3, excuse me. Then we've got number 5, which I will go through. Here we want to find the general solution. And so when you want the general solution, that is the homogeneous plus the particular. So homogeneous is from the previous video. So we know how to do that one. You first get your characteristic polynomial. So we've got r squared minus 3r minus 4 equals 0. This is, let's see, r that's what I've got for factoring. Let me just make sure. R squared minus 4, that's going to be minus 4 plus an r minus 3. Okay, yes, this is the right factorization, which means r equals -1 and positive 4, which means our homogeneous solution is of the form c1 e to the negative t plus c2 e to the 4t. So that is our homogeneous solution. Now we need a particular solution. So we might guess that the particular is going to be of the form a e to the negative t, because our non-homogeneous part is 2e to the negative t. However, I already see in the homogeneous solution that a coefficient times e to the negative t is part of the homogeneous solution, which means if I plug something of that form into the differential equation, it will give me 0, because that's what it means to solve the homogeneous equation. So it can't be a e to the negative t. When you have your first guess already in the homogeneous, which is why you should check the homogeneous first, what you do is you then go up a power in t. So I'm going to multiply a t e to the negative t. And from this point, I'm going to progress as we did in the previous ones. So y p prime is going to be a e to the negative t minus a t e to the negative t. And y double prime, this is the product rule that I'm using here. We've got minus a e to the negative t minus another a e to the negative t, which I'm going to throw in here, making there 2 of them. And then also minus, let's see, we've got a t e to the negative t. Now let me just make sure I didn't mess up my signs. So this is going to be a e to the negative t minus a t e to the negative t. When I multiply through by this middle negative sign here, that's going to give me negative a e to the negative t plus a t e to the negative t. So that should be a plus sign for y double prime. Now I want to substitute in. So we have negative 2a e to the negative t plus a t e to the negative t. That is y double prime minus 3 times y prime. So it's minus 3a e to the negative t minus 3 times negative, so plus 3a t e to the negative t minus 4 times y, so it's going to be minus 4 at e to the negative t, and this should equal 2e to the negative t. Now I want to start simplifying the left-hand side. So for my e to the negative t terms, I've got negative 2a minus 3a, so that's minus 5a, and that is it. So that's going to be minus 5a e to the negative t. And then when I look at the e to the negative t terms, I have 1at plus 3 more, so that's 4 at's minus 4 at's, and so that's going to zero out. So I will write that in just so you see it. That's going to be 0 ate to the negative t equals 2e to the negative t, which means that a must be negative 2/5. Finally, the general solution, yg, is your homogeneous plus your particular. So the homogeneous is c1e to the negative t plus c2e to the 4t plus, well, it's going to be minus 2/5. This is our particular part for a t e to the negative t. And there is our general solution. Enjoy practicing the practice problems at the bottom, and contact me if you have questions.